All right, folks, it's Bass Action, back in action here. In this video, we are going to look at a new way to solve for some parts in right triangles called the geometric mean. Now, the geometric mean is going to be different than the mean or the average that you have been working with up until now. So you definitely want to distinguish the difference between the two so that you don't get them confused. So starting here on the top of the page, I have a definition for a geometric mean. So let's fill in those blanks. We are going to define the geometric mean as x, and a positive x that is, okay? X is going to be the geometric mean between A and B. And you can see here that I have this little formula. So this is our definition referring to this little proportion here. Now, the reason it's called a mean is because when we look at a proportion, these two locations, the bottom left and the upper right, are called the means of the proportion. The A and the B are in what's called the extremes position. Really, what I want to call your attention to is that in the geometric mean formula, the value that is the geometric mean will appear in both mean positions, the bottom left and the upper right. So on the diagonal, these two numbers will always be identical. Sometimes you'll have a variable there, and sometimes you'll have a number here and here, but it will always be the same. So what we're going to do is we're going to look at two examples where we can just algebraically find what is called the geometric mean. And then we're going to look at how this formula relates to some images and some problems that we did back in chapter 7. And we're going to learn a faster way to work with those problems. So let's just take a look real quick at just some basic questions. So finding the geometric mean between two numbers. That means you want to solve for x. So if it's asking you to find the geometric mean, and that's the number you want to find, you'll fill in an x in both of the mean positions, and then the two numbers that it's supposed to be the mean between will go in the other two spots. It's not going to matter whether you do a 5 and a 10 or a 10 and a 5. That's not going to make a difference because we're going to cross multiply. X squared equals 50. Then we're going to take our square root of each side, and we'll simplify that radical. Now, up until now, I've been making a big deal about remembering that plus or minus. However, the geometric mean will always be a positive value, so we do not need to worry about the plus or minus. So our square root of 50 is just going to simplify to a 5 square root of 2. Now, I am skipping over how I simplified that radical because at this point, I'm confident that you know how to simplify radicals. On the next problem, we're going to start off knowing what the geometric mean is, and then we're only going to know one of our numbers. So if you know the geometric mean, then we're going to put that value that is the geometric mean in the two mean positions, and it's going to be between 4 and some mystery number x. Now when we cross multiply, we're going to get a 4x. When we multiply our radicals, remember the 2 times 2 will give us a 4. Our square root of 6 times square root of 6 gives us a 6. So when we cross multiply this, we're going to get 24. So our other value is going to be 6. So sometimes we're going to have some problems that are just going to be very simple like that, and you just plug those values in and cross multiply. Down here is where this is the real heart of the lesson and how this is going to apply for us. In the last chapter, we looked at this particular picture and we identified our similar triangles. What we found is that in this picture, there are actually 3 triangles here: the big right triangle, a triangle on the left, and a triangle on the right. It happened when we had a right triangle and then we drew the altitude from that right angle. And we found that we had 3 similar triangles. The way we did that is we filled in our other right angle, then we colored in the big triangle. Remember we put these little dots here. So the big triangle has a right angle, a red dot, and a blue dot. The triangle on the left should also have a right angle, a red dot, and a blue dot. So this one up here would become a blue dot, which makes our remaining one a red dot. So then when we looked at this triangle name, triangle HUG, the big triangle, was the right angle, the red dot, and the blue dot. So I could put a red dot here and a blue dot here to remind myself of the pattern. So when I complete the triangle names for the other ones, I'll have a triangle. Now I'm going to look on the left. I'm going to go right angle, red dot, blue dot. So it's going to be S-U-H. And then I'm going to repeat that process for the triangle here on the right, right angle, red dot, blue dot. So S-H-G. Slide this down for myself here a second. S-H-G. Now, that's going to be helpful for us because now I've set up some proportions here comparing our different triangles. So there's our S-U-H from right here and our H-U-G from right here. And I want us to complete these proportions. So just using our triangle names, we can see that U-S in the triangle on the top corresponds with H-U in the triangle on the bottom. And HU from the triangle on the top corresponds with UG in the triangle on the bottom. Now, what I want you to notice is now when you look at this proportion that the means are the same. That tells us that segment HU is a geometric mean between segment US and UG. So we're going to come over here to our picture and we're going to find that. That segment HU is right here, and it's the geometric mean between segment US and segment UG. Just going to draw those lines. Now, if we repeat that process with our next, notice I have the same picture here as I had here. Now I've given you different triangles. SHG, that was the one from up here, our big one, HUG right here, and we're going to complete these proportions. When I complete these proportions, HG in the bottom triangle corresponds with SG in the big triangle. And UG in the bottom triangle corresponds with HG in the big triangle, or in the top triangle I meant to say there. And again, notice that on the diagonal, the means match. And if the means match, that tells us that segment HG is a geometric mean between segment SG and UG. So now we're going to come over here and we're going to find those parts. So segment HG, it's right here, is going to be the geometric mean between segment SG and segment UG. Now, what I want you to do is to compare these two pictures. Notice that in both pictures, we have identified as the geometric mean, that's the squiggle, one of the legs in the big right triangle, and the two pieces that we colored with our straight lines were a portion of the hypotenuse from the big triangle and the whole hypotenuse. So on the first one, I had a leg and a portion that was close to that leg and the whole hypotenuse. And in the second one, I had a leg, a portion of the hypotenuse that was close to the leg, and the whole hypotenuse. That is going to be what we're going to call our general formula for it. So what that tells us is anytime we have a big right triangle, an altitude from the right angle, then we can automatically set up the proportion using a leg in the big triangle. That's going to become the geometric mean. So the leg in the big triangle, and it's going to be part of the hypotenuse. And we want to maybe think of that as the touching part or the close part. I usually say touching. Okay? And then we're going to use the whole hypotenuse. And that's the whole hypotenuse in the big triangle. And I'm going to do an example at the bottom so you'll see how this actually is going to work out for us. The last one that we're going to do is we're going to, again, grab two of our triangles. We're going to complete the proportion. US corresponds with SH. SG corresponds with SH. And sure enough, the means match. So that tells us that segment SH is a geometric mean between segment US and SG. US is right here. SG is right here. Again, if you have a big right triangle and an altitude drawn from the right angle, this pattern will always hold true. In general, we can describe that as an altitude, okay, and we're talking about that altitude drawn from the right angle. You're going to have to just get comfortable and maybe even think of it as your own language. The altitude, that's going to become the geometric mean between part of the hypotenuse and then the other part. So just two quick examples, and it's okay if you don't feel super comfortable with after this video, as long as you can follow, that's our most important thing. What I want you to do when you look at this problem down here is I want you to notice that it's a big right triangle, altitude from the right angle. So on your own paper, I want you to cover up the hypotenuse in that big right triangle so that this bottom part kind of disappears for you. And what you'll notice is that the only thing that's left over is this 7, okay? And we're going to put a little squiggle on that, because when we've covered up the hypotenuse, the number that's left will become our geometric mean, okay? So when we set up our proportions, since the 7 is left over and that's on the altitude, we can put that in the mean position. And we know from the general formula up above that an altitude is a geometric mean between a part and the other part. So I can fill in a 5 and an x. Then I can simply cross multiply. I'm going to get a 5x equals a 49. And then it's okay to go ahead and just type that in your calculator, your 49 divided by 5, and you'll get a simple 9.8. Okay? That's okay. Now, let's repeat the process. Notice my other picture has the exact same numbers, but when you cover up this big hypotenuse in the right triangle with the altitude, cover this up, you still have a 7. So we're going to put a little squiggle on that one. That's going to become the geometric mean. This time, instead of having it be the altitude, this is a leg in that big right triangle. Oops, I said altitude, and that made me right altitude. I meant to say leg there. Leg. That's a leg in our big right triangle. Yes, legs in right triangles are altitudes, but I want you to think of this one as the leg. That's going to make it easier for you. The leg from our general formula up above is the geometric mean between the touching part of the hypotenuse and the whole hypotenuse. So this will become an x plus 5. So now I'm going to fill in those values. I'm going to put a 5 and an x plus 5. I can go ahead and I can cross multiply. 5x plus 25 equals 49. 5x is going to equal 24. It's not going to be a nice answer for us, and that's okay. And x will become 4.8. Okay? So again, we're going to do a lot more examples with this in class, but just start to get comfortable with what those general formulas are and how to recognize them.